Hello, this is FlippedHarber for Precalculus. In this video we'll go over section 2.4, Operations on Functions, Composite Functions. The objectives from the text include forming the sum, difference, product, and quotient of two functions. We also want to be able to form the composite function and find its domain. The topics include the sum, difference, product, and quotient of functions, as well as composite functions. The outline for this video will look at the sum, difference, product, and quotient of functions and their notation. We'll find out what the composite function is, as well as look at the domain of composite functions. We'll end by looking at a special case of composite functions. Now the sum, difference, product, and quotient of functions is exactly what it sounds like. F plus g of x means that we take the two functions and add them together. F minus g of x means that we take the function f of x and subtract from it g of x. F times g of x is the product of the two functions. F divided by g of x means that we take f of x and divide by the function g of x. For two functions, f of x equals the square root of x and g of x equals 3x minus 5, let's go ahead and find the sum, difference, product, and quotient of these functions. Now f plus g of x, all we do is take f of x, which is the square root of x, and add 3x minus 5. There's nothing we can really combine or cancel, so we'll leave it like this. F minus g, almost as simple. We take f of x, which is the square root of x, and subtract 3x minus 5. But since we're subtracting the whole function 3x minus 5, including that minus 5, it becomes a plus 5. So watch out for that. F times g of x, we'll take the square root of x, multiply it by 3x minus 5, and about all I can do is distribute that square root of x in. F divided by g means that I take f of x on the top, g of x on the bottom. And again, I don't have much to cancel here, so I'm just going to let it sit like that. Composite functions means that we're taking one function and plugging it into another. Now this is read f of g of x. That's not an O, that's actually a circle symbol, and it means the composite, that we're plugging g into f. So I like to refer to that first function, f in this case, as the outer function. G is the inner function. It's getting plugged into f. Let's take our two functions and find the two composite functions, f of g and g of f. The difference between the two is which function is the outer function and which function is the inner function. In our first one, f of g, we're literally taking g, that is 3x minus 5, and plugging it into f of x. So we get the square root of g, or the square root of 3x minus 5. Again, there's really nothing for me to combine or cancel, so I'll let it sit like that. Now g of f means that we're taking the square root of x and plugging it into g of x. So we get 3 times the square root of x minus 5. Now let's talk about the domain of composite functions. First of all, any number or numbers that is excluded from the original component function is automatically excluded from the composite function. So if you can't plug 1 into f of x, you can't plug 1 into any composite function with f of x, whether f of x is the outer or inner function. Now there may be additional numbers that have to be excluded based on the new function that we create. So let's go ahead, take our two functions that we've been working with, find f of g, which we've already done, and let's talk about the domain of f of g. Now the first thing to look at is what numbers are excluded from the original functions, from f of x and g of x. Well, g of x, nothing's excluded. G of x, the domain, is all real numbers. But f of x, we can only plug in numbers where x is greater than or equal to 0. So automatically, we have that exact same limitation on any composite function, including the one that we're working with. Now, are there additional numbers that have to be excluded? Well, f of g is a square root function, so 3x minus 5, that is the stuff under the square root, has to be greater than or equal to 0. If I solve this new inequality, I get the fact that x has to be greater than or equal to 5/3. Now, I've got two limitations here. X has to be greater than or equal to 0. X has to be greater than or equal to 5/3. Now, if x is greater than or equal to 5/3, it is by default greater than 0. So it's actually this new limitation that I'll use as my domain for the composite function. So the domain is the set of x such that x is greater than or equal to 5/3. Now let's look at this special case. F of x equals 2x minus 6 and g of x equals 1/2 x plus 6. Let's go ahead and find the composite function f of g. That means that we're taking g of x and plugging it into f of x. So where we see x in f of x, we're going to replace it with the whole function g of x. Now, I definitely want to try to simplify this. And the first thing I'm going to do is multiply in that 2. What it's going to do is cancel the 1/2. So when I do that, I have x plus 6 minus 6, which is equal to x. Now, why is this a special case? Well, we'll talk about this special relationship later, actually in section 4.1. But whenever composite functions equal x, we have a special relationship between the two smaller component functions, f and g. More about this special relationship in chapter 4, but on your homework today, you do have some problems where they want you to show that a composite function is equal to x. All right, we're all done. Time for homework. I'll see you in class and I'll see you online.